Hello everyone. I would like to go through this worksheet on normal distribution and the normal curve, where we learn how to find z values from a given area or how to find the area from a particular z value and so on. All right. There is a lecture posted on it, and much of this was demonstrated to you on the lecture during the lecture. However, we will work through specific example problems step by step, and I will show you how you should be answering questions on this topic, right? So it says here a variable is normally distributed with mean 6 and standard deviation of 2. Find the percentage of all possible values of the variable that lie between 1 and 7. All right. So over here, let's just go through this explanation of the question first. It says a variable is normally distributed. So the information they've given us already is part of the question is that a variable is normally distributed. And that's very important. That's a very important piece of information, because if we have to use the standard normal curve, then the variable better be normally distributed. And then they've given us information on the mean and the standard deviation. We do need these two pieces of information to find z values. So I'm going to note those down, especially here. All right. So mu equals 6. Population mean is equal to 6, and the standard deviation is equal to 2. So the question is, find the percentage of all possible values of the variable that lie between 1 and 7. So find the percentage, meaning find the percentage of observations of all possible values. Refer to all observations that lie between this range of values 1 and 7. So step 1 is to sketch the normal curve associated with the variable. So what I'm going to do is first always begin these questions with drawing a curve. It makes it so much that itself will guide you through the process. So sketch the normal curve, draw a curve here. Okay, symmetric curve will have its center. All right, the mean will be located at the center in a normally distributed curve, in a normal distribution. So mu will be equal to 6, standard deviation is 2, and then the two values, the two observations that between which we want to find the percentage will be are 1 and 7. So if 6 is here, then 7 will be a little bit to the right of 6, right over here, and 1 will be way to the left, probably somewhere here. Let me mark it here. All right, and I'm going to extend the lines vertically from from 1 and 7. Okay, and in order to find the percentage, remember, in order to find the percentage of observations, we need to find the area. The percentage, area, they correspond with each other, all right? So whenever they're asking you for the percentage, that means immediately you should know that you have to find the area, in this case, between these two values. So we have drawn our figure. We have shown where the mean is, better be right at the center. We've shown where 7 would be relative to the mean, where 1 would be relative to the mean. 1 is less than 6, so it will be to the left of 6, and 7 is greater than 6, so it will be it's slightly to the right. So we extended these vertical lines, and now we can shade the area that we will be looking for. Okay, this is the area we will be looking for. All right, now, in order to find the area, we cannot go to the table using actual values, right? The table only works with z values. So what I'm going to do is I'm quickly going to switch to the table and show show that to you. So this is the Z table that we will be referring to, which has all the areas for specific Z values, right? The Z table is broken up into two sections. The first section has all the negative Z values, and if you go down below, this has all the positive Z values. And the areas on this table are all always areas to the left of a specific Z value. All right, so we are not ready to come to this table yet because we do not have the Z values. So far we just know the X values, right? X values, the actual values. So let's go back to our worksheet and calculate the Z value. So in step 2 it says find the Z scores for the delimiting X values found in step 1. So the delimiting X values are 1 and 7. So we have to convert them to Z scores. All right. So I'm going to draw another diagram here, and then we'll calculate the Z scores. Or maybe we'll first calculate the Z scores and then we will draw the diagram. Either way is fine. So we are going to first find the Z value for X equal to 7. All right, I'm first finding the Z value for the higher value, which is a 7. What is the formula for Z score? Again, you can go back to your formula sheet. It should be here, over here, up here. All right, standardized score for variable X, Z equals X minus mu divided by sigma. When we are working with individual observations, then we use this formula. All right, so let's go back to our Word document here. So the formula is, what's the formula for Z? Z equals X minus mu over sigma. All right, so Z will be equal to X is 7. What was mu? Mu was 6 and standard deviation was 2, correct? So 7 minus 6 divided by 2 is 1/2. All right, is 1/2 or 0.5. Now we also have to find the Z value for X equals 1, correct? We found the Z value for X equals 7. We'll find it for 1 now. So Z value for X equal to 1 is, now same formula, but this time 1 minus 6 divided by 2, which is negative 5 over 2, which is going to be negative 2.5. All right, so I'm going to draw my curve at this point. All right, here's my curve. So my mean, now my horizontal line, instead of having the actual values for mean and then the observed values 1 and 7, it will now be in terms of Z values. So the center point where the mu was located is going to have 0, going to be 0. Where there was 1, it's going to be negative 2.5, and where there was a 7, it will now be 0.5. All right, so I'm going to extend these lines vertically and shade this area. This is our region of interest. All right, so now that we have our Z values, we need to find the corresponding areas. So area to the left, is what we are looking for. All right, so I'm going to first find the area to the left of 0.5. All right, so let's go back to our table. All right, so 0.5 is a positive value, so I'm going to look up the positive Z table. 0.5 is 0.6915. See, 0.50, the second decimal place is 0, so 0.50, this is our area, 0.6915. So let's go back, is 0.6915. And then we have to find the area for negative 2.5, right? So 0.69915 is actually all this area. It's this entire area, all this area. Okay, so we have to subtract this area as well. We have to exclude the area to the left of negative 2.5, and that's the reason we need to find the area to the left of negative 2.5. So we can go back to your table, but this time we have to look at the negative section of the Z table. So negative 2.5 is right here. Let's pull up. 2.5 is 0.0062, correct? So 0.0062. 0.0062. So now you have to subtract the two areas. You have to subtract this portion, right? This area was 0.0062 and this whole area was 0.6915. But we are only interested in this portion of the curve, the area under this portion of the curve, right? So that's why we have to do 0.6915 minus 0.0062, which will give us a value of 0.6853. 0.6853. All right, so we found the areas. Actually, we did step 3 all in as part of step 2. So, you can just direct it up here. It's all there. So, interpretation, always, all statistical work has to be, they have to be interpreted correctly. So, interpretation will be, they had asked for percentage, right? Make sure you're answering the question. It said, find the percentage of all possible values between 1 and 7. So, I'm going to write 68.53%. You have to convert your 0.6853 to percentage form. So 68.53% of all possible values or observations lie between the values 1 and 7. 1 and 7. Okay, so this is how you're going to answer these questions step by step, and it's very crucial that you support your work with sketches, with diagrams. All right, that's you do need, and the question will say show your work with a diagram. All right, so don't miss showing a diagram supporting your work. Now part B of the question says what percentage of observations exceed 5? So it's the same question. We'll be dealing with the same mean value, same standard deviation value. But to this time, we want to know what percentage of observations lie or exceed the value 5. All right, again, same process. Let me list the values for the mean. Mu equals 6 and standard deviation given to us was a 2. So let's first draw our curve. Okay, this is our curve. Not the perfect curve, but I think it'll work. At the center, we have mu equals 6, and then standard deviation will be 2. And where will 5 be located? It said the individual observation that we are looking for, whose area we want to find. All right, so it'll be 5 will be little slightly to the left of 6, correct? It's less than 6. So it'll be to the left. So this will be 5. This is where 5 is located. So just draw a vertical line up to the curve. Now, exceeds means what? Exceed means greater than, correct? It means greater than 5. So that means we want to know what percentage of values are greater than 5. So it's going to be the area to the right side. Greater means everything to the right. Okay, so this is the area that we are looking for, is all this area to the right of wherever 5 is. So this time we are not looking for area between two values, but to the right of a particular value, which in this case is 5. Okay, so again, so far we just have actual values. Before we can go to the table to find the area, we have to find our z values, right? But this time only one z value corresponding to 5 is what we need to find. So the formula, always have the formula in front of you, all right? It makes things so much easier. So x minus mu divided by sigma. So x is 5 minus 6. Mu 6 divided by sigma is 2, which is negative 1/2, correct? Which is negative 0.5. So now we have to go to the table with a z value of negative 0.5 and find the corresponding area. All right, so let's go to the table. So negative, we are on the negative table, negative section of the table. So negative 0.5 has area 0.3085. So this is the area. However, this is the area to the left of negative 0.5, isn't it? So if I go up, okay, just remind yourself by looking at this diagram, this table only gives area to the left, all right? So when you pick a value from here, this represents area to the left of a particular z value. In this case, it's 0.3085. Right? So it's area, the area corresponding to z of negative 0.5. Now, not just the area, but its area to the left. Let's be very specific here. Let's be precise. Area to left corresponding to z of negative 0.5 is 0.3085. However, we are looking for area to the right, correct? So to find area, therefore area to right of z equals negative 0.5 is 1 minus, correct? 1 minus 0.3085, which is equal to 0.6915. And I'm going to illustrate this with a picture again. So here's our standard normal curve. We have, but this time it'll be all in terms of z. So the center point is going to be marked as 0, and then the z value pertaining to an observed value of 5 would be negative 0.5, which is slightly to the left of 0, negative 0.5. Let's mark it here. And we were looking for area to the right to indicate what values or what percentage of values exceed 5, correct? So the corresponding z value for 5 is negative 0.5, and we found the area to the left. So all this area is 0.3085. We are interested, our region of interest is this blue section. So you have to do this. It will be 1 minus 0.3085, which is equal to 0.6915. All right, so that's our area. We have to, however, interpret it and answer the question that has been asked of us. So 69.15%. You have to convert it to percentage because the question says what percent. That's what it asked us. 69.15% of all possible values, observations exceed 5. Exceed 5. All right, so we have completed 2 parts of this question. I think there is a third part as well, which is most likely area to the left. Let's continue with the last part of this question, where they want to know the percentage of observations that are less than 4. Again, same process. Start with sketching the normal curve. Okay, so let me take out my pen here. So think about it. Are less than 4 means observations that fall below 4. So that would mean less than 4, correct? So when you're sketching your graph, here's our normal curve. All right, again, the mu equals 6 and the standard deviation was 2, correct? So I'm sketching the normal curve. This is not a standard normal curve. This is just a normal curve with the actual values. Mu goes at the center, standard deviation is 2. So 4 is the delimiting value, right? So we are going to mark 4 along the horizontal axis relative to 6. If 6 is at the center, 4 being less than 6 will fall to its left. So let's mark it somewhere here. All right, let's mark 4 somewhere here. And then I'm going to extend the line, a vertical line, from 4 to go up and touch the curve. And then the area we are looking for is, since it's less than 4, it'll be the area to the left. All right, so what I'm going to do is I'm going to shade my region of interest. This is my region of interest, area to the left. So this is the area I'm looking for. Now, we can always find the area from the table. However, we cannot go to the table with actual values, actual observation values. We have to convert it to a z value first. So let's do that here in the next step. Find z of, what's the x value? 4, correct? So the formula, again, let's write it out here. Z equals x minus mu over sigma. So x in this case is 4. So 4 minus 6, mu is 6, divided by 2, which will be negative 2 over 2, which is a negative 1. All right. So now I'm going to redraw my, let me just make some space here. Lock this. So let's draw a standard normal curve this time with showing z values on the horizontal axis. All right, so this time the center point will be a 0, all right, because now we are showing z values on the x-axis, and -1, since the z value we found for a particular observation was -1. Let's mark -1 somewhere here, extend the vertical line up to the curve and shade the area we are looking for, right? So the area we have for the area, and this is the area to the left, correct? So that makes things easy for us. Area to the left of z equals -1. We are going to go to our table now. So just a second. Let me pull up my... So here's our table. We were looking for the area corresponding to a z value of -1. So we have to look up the negative section of the table, a section of the table that has all negative values for z. And here it is. We have to go down to where -1.0 is. Let me pull up the edit so I can maybe... So -1 is right here, and the corresponding area for -1.00 would be 0.1587. All right, so I'm going to take this value and go back to my worksheet. All right, it is 0.1587, and that table always gives area to the left, and that's the area we are looking for. So for this time we do not need to subtract anything from 1. That would be only when we are looking for area to the right. So we got our the proportion of observations. That's what the area means. This area value of 0.1587 tells us the proportion of observations that would fall below a value of 4. However, they asked us to give them the percentage, so let's convert this to percentage. So the way we are going to write it is 15.87% of possible values or observations are less than 4, right? The next problem on the worksheet for normal distribution is an application-based problem. It's about the New York City 10-kilometer run. As reported in Runner's World magazine, the times of the finishers in the New York City 10-kilometer run are normally distributed with mean 61 minutes and standard deviation 9 minutes. So the finishing time, the average or the mean finishing time of runners in the New York City 10K run is 61 minutes and the standard deviation is 9 minutes. So let's write down our data here. Mu equals 61 minutes and sigma or standard deviation is 9 minutes. Now the question says determine the percentage of finishers with times between 50 and 70 minutes. In other words, they want to know the percentage of finishers who finished within the time of 50 and 70 minutes. So these are going to be 50 and 70 minutes are the individual observations. So I'm going to label X sub 1 as 50 minutes and X sub 2 as 70 minutes. All right, so given this data, we will have to find the percentage of finishers. Again, percentage translates back to area under the curve. And area under the curve goes back to z values, because you need to know the z values in order to find the area under the curve from the table. All right. And then, of course, we have to start with x sub 1, x sub 2, and have this data available to us in order to be able to calculate the z scores, the z values. All right. Now, we have the steps given here all at once. So we will go through it step by step. However, just want to mention that on the test, you will not be given the steps laid out like this. You simply have to know the steps. Because this is a practice, we are just learning at this point. That's why we've given out the steps here, but on the test, you will have to know the steps. All right. So step 1 was to sketch the normal curve associated with the variable. So I'm going to draw the curve always. All right, always begin by drawing the curve. It's going to give you some directions on how to go about it, even when the steps are not given to you explicitly. Okay, so here we have a normal curve. This is not a standard normal curve, just a normal curve with actual value. So the center point of the curve is somewhere here, let's say, and that's 61, right? Mu equals 61. It's going to be at the center point of the horizontal line and therefore of the curve. And then standard deviation is 9. And then we have to show where 50 and 70 are with respect to the center point. So 50 would be to the left because it's less than 61. So I'm going to mark it somewhere here. Let's mark it here. And then 70 is going to be to the right of 61, right? It's going to be somewhere here, let's say. And then we extend the vertical line from 50 and 70 and shade the area, because shade the area between those two lines. But that's going to represent our region of interest. All right, region of interest. That's our region of interest. We have to find this area in order to find the percentage of finishers with this time between 50 and 70 minutes. Now, we cannot go to our table to find the area with actual values. We need to convert the 50 and 70 to z values, right? So let's find the z value. So in step 2, it says shade the region of interest, which we already did. We shaded the region of interest and mark its delimiting values. The delimiting values are this 50 and 70, right? And then in step 3, it says find the z-scores for the delimiting values, that's 50 and 70. Again, the formula for the z value, you may want to keep that before you. Again, it'll be available on the formula sheet, but by this time you should have it memorized. X minus mu over the standard deviation, sigma. All right, so for z sub 1, which is 50, let me find z sub 2 first, okay? Z sub 2 is 70, all right, because we have to do the subtraction from the higher value. That's why I'm going to work z sub 2, but you can find z sub 1 first as well, doesn't really matter. So z sub 2 is of 70 will be x, that's 70 minus 61 divided by 9, correct? So 70 minus 61 is 9 divided by 9 is 1. That's our z value. For z sub 1, which is 50, it'll be 50 minus 61 divided by 9, correct? So 50 minus 61 will be negative 11 over 9, which is negative 1.22. Okay, so we have 1.00 as z sub 2, the z score for 70, and we have negative 1.22 for the z value of 50. So I'm going to now draw another curve here before we go to find the area. This time it's going to be the standard normal curve. All right, standard normal curve center point is going to have a z value of 0. And then what were the two z values we found? On the left side, there'll be negative 1.22. So this, let's mark this as negative 1.22. In the standard normal curve, the horizontal line is z values. In the normal curve, it's the x values. That's the difference. And on the positive side, we have 1. All right, let's mark this as 1. And again, extend vertically the lines from negative 1.22 and positive 1. Shade the region of interest. Okay, that's the area of interest or region of interest, whose area we have to find. And now to find the areas, we have to go to the table. Again, keep in mind the area is always on the table is always to the left of the curve. Now, because this is the area between 2 points, we have to first find the area to the left of the higher z value, which is 1.0. We have to find all this area. And then we have to find the area corresponding to negative 1.22. So the area to the left of negative 1.22. And then finally, we have to subtract this area from this entire area. All right, so let's go to our table and find the area. So this is area to left. Area to the left of 1.00. So 1.0 is a positive value, so I'm going to go to the positive section of the table, which is here, right? 1.00 z value has an area 0.8413 to its left. So I'm going to say 0.8413. Okay. Now, so that's all this area here. It includes the yellow area as well as this area to the left, all right, left of negative 1.22 as well. We have to find the area of to the left of negative 1.22 now. So now we have to refer to the negative section of the table. So negative 1.2 is right here. Let me see if I can pull up the pens. Just a second. If I can. Okay, I'll let it go. Negative 1.22. So negative 1.2 is here, and negative 1.22 is this value here. All right, this negative 1.112. Okay, I got my pens out. So negative 1.2 is here, and up here is 0.02. All right, is 0.02. So let's go down and pick up this value, 0.1112. So let's go back here and write 0.1112, and then you have to subtract. That's this area, right? It's this area. So you have to subtract, and that's the common area, kind of. It's a common area. So we have to subtract the 0.1112 and we will come up with a value of 0.7301. So that means 73.01% of finishers finished between 50 minutes and 70 minutes. All right, so let's write it down as a sentence here. 73, the final answer should be written like this: 73.0% of finishers had finishing times between 50 minutes and 70 minutes. Okay, so that means this region of interest, the area of this region of interest is 0.7301. Okay. The next part of the question says determine the percentage of finishers with times less than 75 minutes. Again, start by drawing the diagram. So I'm going to here draw the picture of our standard. I'm going to draw the Z curve as well as, or I'm going to show the Z values and the observation values in the same curve this time. All right, instead of drawing two separate curves, I'm going to represent everything in the same curve. So you may want to just watch and see how we do that. So in the center point has a mean value or X bar value, mean value, right? The population mean of 61 minutes. Standard deviation is 9 minutes. And our X value here is 75 minutes. So where would 75 be? Over here, it would be somewhere to the right of 61. It's greater than 61. So I'm going to mark it somewhere here. All right, somewhere here maybe. All right, so let's mark 75, X equals 75 there. So if you raise the vertical line from there, then it separates the curve into two regions. So the region that we are interested in is, it says less than, correct? Less than 75. So all this area to the left of 75. So let's shade that area, all this area to the left of 75. This is our region of interest. Region of interest. So we have to find the area of this yellow region. However, we cannot go there with X values. We have to go to the table with Z scores, correct? The table only works with Z scores. So we we have to convert X to Z value, and that would be Z equals X minus mu over sigma, which is 75 minus 61 over 9, which is 14 over 9, and will give us a value of a Z score of 1.56. So now I'm going to write my Z values on the same curve, just because to maximize the space, to optimize the space, so to speak. All right, so 0 is the Z value, and the corresponding Z value for 75 is 1.56, what we found here, right? 1.56. So now let's go to the table and find area to left, and that's our region of interest, all the area to the left. So find area to left of Z equals 1.56. Let's go to our table. So we have to refer to the table with the positive values. Let's remove these markings here. So the positive table is up, no, down. 1.56. So 1.5 is here. We have to look for the column which has the second decimal place of 6 or 0.06. So 0, 1, 2, 3, 4, 5, 6. It would be this value really. All right, so 0.06, 1.56, 1.5, and this column is for 6 in the second decimal place, 0.9406, and that's our answer. All right, so area to the left is 0.9406. So you have to give your final answer in percentage form. So you're going to say 94.06% of runners at the 10 km New York City 10 kilometer run had finishing time less than 75 minutes. Less than 75 minutes. All right, so there are 2 more parts to this question. We will solve those before we end the worksheet on normal distribution. Now, part C of the problem is slightly different from the other parts that we had worked on before. For this question, it says obtain and interpret the 40th percentile for the finishing times. Now, in the previous question, they had given us the x values. All right, they had given us the x values, the mean and the standard deviation, and they asked us to find what percentage of observations lie to the left of a certain value of that particular x value, or to the or between 2 values, and so on. For this question, they have given us the percentage, and they are asking us to find the x value corresponding to that percentage. Now, they've used the word percentile here. What does percentile mean? Percentile is essentially the same as percentage, except that percentile also tells us that the percentage is to the left of a certain observation, right? So when somebody says you have been placed at the 40th percentile, that means that there are 40% of observations below your score, or below the value you own. All right, below your score. So let me write that down. All right, percentile means, especially 40th percentile, as in this case, means 40% of observations are below a certain value. Below a certain value. And this question is saying below what value. We have to find that certain value below which lie 40% of observations. Again, begin by drawing the curve. All right, so I'm going to first draw a diagram here, a standard normal curve. This time we have to start with the standard normal curve, because we are backtracking. In the previous question, we were given the x value. We used the x value to find the z value, and then once we found our z value, we found the area, right? We found the area to the left, and then once we found the area, we converted that to percentage. Here, they've given us the percentage. We have to convert that to area, and then from the area, we have to find the z value using our table, and then once we have our z value, we are going to find our x value. All right, so we are going to backtrack the steps we have performed so far for the previous problems. So 40th percentile, let's demonstrate that in using our standard normal curve. Again, the center point is where we will have 0 or the mean of 61, which will have a corresponding z value of 0. Now, 40th percentile means it'll be somewhere here, probably, I don't know, let's mark it here. 40th percentile is less than 50 percentile, correct? Remember, this is a symmetrical, a normal curve is always a symmetrical curve. It divides the center point will divide the curve into two equal parts, 50% on the left hand side, 50% on the right hand side of the center point. And because it says 40th percentile, it will be on the left hand side because it's less than the 50%. So I'm going to extend the curve up to and then shade the region to the left. All right, and I'll say this area is 0.40. That's the area. Okay, and we have to now find the z value whose area to the left is 0.40. So find, what we are doing here is find the area whose, find the z value. Excuse me, I'm sorry, I misstated. Find the z value whose area to the left is 0.40. Again, let me repeat this. How did I get 0.40 for the area? I took this 40th percentile information. I know 40th percentile means 40% of observations are less than a certain value. In other words, 40% of observations are to the left of a certain value. If it's less, that means it's to the left, right? And then I converted my percentage value to decimal by dividing by 100. All right, just convert your percentage to area. So we have to go to our table to find the corresponding z value. Let's pull up our table, but this time we are first going to look at the values in the body of the table and look for 0.40. Now, because it's to the left, the area is to the left, and the delimiting point, right? This is what we are looking for. We are looking for this mark here, which is on the negative side of the horizontal line. The z value will be a negative value, correct? So we are going to go back and look at the negative table and try to find 0.4 somewhere here. So we have 0.301, 0.4, right? So 0.4, 0.3, 0.4. We are getting closer. 0.4 is 0.3897, 0.403, correct? So minus 0.2, and then let's pick 0.3974 is the closest. So 0.2, this is 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. This is 0.401 and 0.3974. This is the closer value. All right, 0.4013, which is 0.4013 is closest to 0.40. The corresponding z value is negative 0.2, and this column is for the second decimal place of 5, right? So minus 0.25 is the z value. So let's go back to our worksheet here. So it's z equals negative 0.25. Okay, so we got our z value now from the table. We have to find the corresponding x value. Find corresponding x value. All right, so the formula is, you can either solve for x in the equation z equals x minus mu over sigma, plug in the value of mu, mean, plug in the value of the standard deviation, plug in the value of the z score you just found and solve for x. Or you can just first solve for x. So x will have x equals mu plus z times sigma. All right, so it's going to be x equals, mean is 61 plus z is negative 0.25 and sigma is 9. So x will be equal to 61 minus 2.25 minus 2.25 for an x value of 58.75. Okay, so the x value is 58.75, which corresponds with a z value of negative 0.25. All right. It corresponds with a z value of negative 0.25. So again, you have to write out your answer as a sentence saying that the 40th percentile for the finishing time is 58.75 minutes. Right? The last question says find and interpret the 8th decile for the finishing times. Now this question is similar to the previous one we worked before. However, instead of giving us the percentile, they've given us the decile. Now decile has to do with the number 10. Deca, decile, these have to do with the number 10. So 8th decile means dividing the number line into 10 units. So they're starting from here. Let's say this is 1, then the next one is 10, 20, 30, 40, 50, and so on. All right, we divide the number line by tens in intervals of 10, and 8th decile means 80. All right, so it means 80. So it essentially means 80th percentile. Right? Percentile means dividing the number line into 100 pieces, 100 parts. Decile means dividing the number line into 10 parts, right? Now, we have to work this problem the same way as the previous problem, now that we know that 8th decile is the same as 80th percentile. So again, percentile means percentage of observations to the left. That means 80% of the observations lie to the left of a certain value. So we are going to start by drawing our curve as usual. All right, so here's our curve, and we have to first shade the 80th percentiles. Again, center point is going to be where the mean is located, correct? Mu equals 61, so that will have a z value of 0. And then, of course, standard deviation is 9, and 80th percentile will will be a value, all right? So the particular z value and hence the corresponding x value will be located somewhere to the right of the center point. So I'm going to mark just randomly a point on the right hand side of the center point and pull the line up vertically and shade the area to the left. All right, we shade the area to the left, and that represents an area, all right, area of 0.80. You have to convert your 80%. All right, so let's write that here. The steps: convert 80% to decimal, which will give us the area, to get the area. All right, and in this case it's 0.8. So this area is 0.8. So now that we have the area of 0.8, find the z value. The z value whose area to the left, is 0.8, correct? Go back to our table, and now we have to look for where 0.8 is in the middle section of the table. 0.8 will be, we're getting closer, 0.7995 is the, here 0.7995 is the closest to 0.8. So let's look at what the corresponding z value is. If you go to the left horizontally, it's 0.8, and the second decimal place is a 4, so 0.84, positive 0.84. Let's go back here. So z equals 0.84. All right, so now that we have our z value, we know what our mean is, we know what our sigma is, we need to find what the x value is. Again, you can either solve for x in the formula x minus mu over sigma by plugging in the values for the mean, the standard deviation, the z value, and you solve for x, or you can just do this. X will be equal to, whether you solve it from this equation or directly use the formula x equals mu plus z times theta, or sigma, sorry, I keep saying theta, it's sigma, right? So x will be equal to 61 plus 0.84, what we found from the table, times sigma is 9, correct? 9. So we will have x equals 61 plus 0.84 times 9 is 7.56 for an x value of 68.56. And then the final answer will be the 8th decile, 68.56. The 8th decile for the finishing time is 68.56. All right, 68.56 minutes if you want to be more precise. All right, so that completes all the problems on the worksheet for normal distribution. So by solving these problems yourselves, you should have a good handle over this topic now, how to work on the problems.